Good day, everyone. Welcome to Nuclear Chemistry and Energy. This is another lecture series that is under Unit 2 about energy. All right. All right. So before we dive into the main topic about electrochemistry, I want you to recall about the atomic structure. So atomic structure, we have tackled about this when we had our first meeting. So remember the different atomic models, okay, presented by John Dalton, uh, Ernest Rutherford, okay, and Chadwick, okay. So everyone in that atomic theory, but in these times, in these modern times, we follow the modern atomic model. Okay, so you recall from that. So the atomic structure, you have been oriented that it consists your atom. Okay, this is the atom, and it consists of three subatomic particles, right? We have the electrons, which are negatively charged, your protons, which are positively charged, and the neutrons, which are neutral. There is no charge in that. Okay, and we have talked about in our electrochemistry that it is more about removing and adding electrons, right? If we are to eliminate electrons in an atom, it changes its charge, right? So in our electrochemistry, we balance the charge. Okay? So hindi natin pinapakialaman ang protons and neutrons dyan, yung nucleus. Okay? So in this atomic structure, I want you to remember the atoms consist of two parts. Okay? Ibang parts sa subatomic particles. Okay? So you can see the nucleus and the electrons. So the nucleus, it consists of these uh, protons and neutrons. So they are merged together. So you cannot really, kumbaga, tell them apart. Okay, so you just know that it has a positively charged atomic particle there, and neutrally charged particle inside the nucleus. Okay, so I want you to remember that in the electrochemistry, we talk more about balancing the electrons, the flow of electrons, okay? And uh, the chemical reactions involved to produce an electricity. In nuclear chemistry, we talk about the nucleus. That's why it is nuclear, okay? Nuclear because we talk about the nucleus here. So, tapos na tayo sa electrons, we move on to the nucleus. Okay, so that is uh, nuclear chemistry. So this is just a comparison of the nucleus and the electrons. So the nucleus, it consists of the 99.9% the mass of the atom, and it is concentrated in the nucleus. So ito yung mabigat talaga. Ang nagpapabigat talaga sa atom is mismong nucleus, di ba? Sinabi ko na yan. And the electrons ay sobrang light lang nila, but it consume, or kumbaga, it has the most volume. Okay? Kumbaga, i-compare nyo ang solid na particle sa gas particle. Okay? Kapag i-compress mo ang gas particle, the volume decreases, right? And yung compressed na yun, parang yun ang nucleus. But, of course, it's not comparable in terms of the parts because the electrons, they cannot it doesn't mean that if you compress an electron becomes a nucleus. It's just an example in terms of volume. Okay, so we have talked about this in our first meeting, right? That the structure of an atom is like a stadium, right? Yung nucleus doon ay parang sand lang doon sa stadium. Yung buong volume ay yung electrons. But in terms of mass, ang pinaka nagko-contribute is the nucleus. Okay? Ayon. And then the nucleus, it is positively charged. Positively charged because it contains the protons. Okay? And the electrons, of course, it is negatively charged. Nucleus also, it has a strong nuclear force which hold the protons together. So this is a strong force that prevents the neutron and the proton to drift apart. Okay? And the electrons, it has a weak electrostatic force between the electron and the neutron. So ito yung parang dahilan din na hindi dumidikit ang electron sa mismong nucleus. Okay? And another one, we have, it is responsible for nuclear reactivity. Okay? Nuclear reactivity. And the electrons, it is responsible for chemical reactivity. That's why we utilize these electrons to producing an electricity because it is responsible for chemical reactivity. And electrochemistry is all about chemical energy into electrical energy. In nuclear chemistry, we talk about more about the nucleus, right? And we have mentioned that the protons, these makes up the identity of an element, di ba? Ito yung nagbibigay ng identity ng element. But what if we bombard this nucleus by a neutron or another proton? So it changes its identity. And this is responsible for being a nuclear reactive. Okay? So parang nagbibigay siya ng another identity. Okay? Nagbibigay siya ng force from that. Okay? Yun ang gusto natin. We harvest that force. We harvest that energy. Okay? That is nuclear chemistry is about. Okay? Alright. So, to have a proper definition on nuclear chemistry, okay, nuclear chemistry, it is the study of the reactions involved in changes in the atomic nuclei. Okay, so I have told you about that a while back. So this branch of chemistry began with the discovery of natural reactivity by Antoine Becquerel and grew as a result of subsequent investigation by Pierre and Marie Curie and other scientists. Okay. So, what is the nature of the nuclear reactions? So, with the exception of hydrogen, all nuclei contain two kinds of fundamental particles. These are the protons and the neutrons. So, please take note that your nuclei term here, it is the plural form of nucleus. Okay? So, some nuclei are unstable. So, because they are unstable, they emit particles and electromagnetic radiation spontaneously. Okay, spontaneously, it means that without any external force. Okay, walang human intervention. It occurs on its own. Okay, because of the instability, they emit particles and they emit electromagnetic radiation. They emit energy. Okay, so the name for this phenomenon is radioactivity. Okay, So phenomenon na being unstable of nuclei, it is called radioactivity. So elements having an atomic number, okay, greater than 83, they are most likely radioactive, or they are unstable. Their nucleus are unstable. So another type of radioactivity known as nuclear transmutation. So it results from the bombardment of nuclei by protons, neutrons, and other nuclei. So some cases, heavy elements are synthesized from lighter elements. So this type of transmutation occurs naturally in outer space. Okay, but it can also be achieved artificially. So what do we mean by nuclear transmutation aside from this, of course, this definition? Try to remember it this way. Kapag meron kang nucleus here, okay? For example, ito yung nucleus mo. So, huwag na nating i-draw ang ating protons. Ang electrons, I should say. So, if you bombard, ibig sabihin ng bombard, kapag nilagyan mo pa yan, or tinapon-tapon mo ang neutrons, or proton, or di kaya another na nucleus, dyan, dito, okay, makakabuo siya ng bagong nucleus. Makakabuo siya ng bagong nucleus. It can be heavier or lighter. And this phenomenon, it occurs naturally sa outer space. But of course, dahil alam natin ang phenomenon na ito, we can replicate this sa laboratory. Okay, pero hindi sa laboratory natin sa CSU. Okay, hindi natin kaya yon. So, it can be achieved artificially by experts, scientists, to harness or to harvest energy from this bombardment. Okay? So what is the difference between chemical reaction and nuclear reaction? So I have told you a glimpse about the difference kanina, but isa-isahin natin. Okay, so chemical reaction, atoms are rearranged by breaking and forming chemical bonds. Only electrons in the atomic or molecular. Okay, so ibig sabihin, sa electrons lang. Kumbaga sa atomic structure natin, sa labas lang ang chemical reaction. Okay? Sa chemical reaction din natin, orbitals are involved in breaking and forming the bonds. So reactions are accompanied by absorption. Okay? So orbitals, yan yung layers, okay, layers of the electrons. Okay, they attach themselves to positive or kumbaga metals and non-metals, ganun. So that is chemical reaction. So release of relatively small amounts of energy, and the rates of reaction are influenced by temperature, pressure, concentration, and catalyst. Okay, sa nuclear reaction natin, elements or isotopes of the same elements are converted from one to another. So protons, neutrons, electrons, and other elementary particles may be involved. So reactions are accompanied by absorption or release of tremendous amounts of energy. Tremendous, okay? Dito ay relatively small amount of energy. So the rates of reaction normally are not affected. Okay, not affected by temperature, pressure, and catalyst. So this is, this involves a lot of energy sa nuclear reaction natin. That's why we have a nuclear power plant. Okay, we can harness energy from the nuclear reaction because it can release tremendous amounts of energy. Okay, so we can be more kumbaga we can have more energy because of nuclear reaction uh, compared to chemical reaction. Okay, so yes, we can produce an energy from a chemical reaction, as we have talked about voltaic cells, right? Those are also energy, and we can produce energy, electricity from these chemical reaction, pero walang-wala yan sa nuclear reaction. So if we are to harvest an energy from nuclear reaction, it can have a tremendous produce of energy. Okay? Of course, we need experts. We need scientists that are really specialized in nuclear chemistry for these to be safe from the environment, from the people, and of course the workers. Ganon. Okay? So it really fascinates me to think about Philippines having a nuclear power plant. Okay, it's not as dangerous as you might think it is. So as long as you know how to counteract this radiation. Okay, so in the latter parts of this discussion, we will encounter the types of radiation and how to counteract. Okay, kumbaga kapag naglalaro kayo ng Mobile Legends Bang Bang, okay, there are items there na pang damage and there are counter items para defense. Okay, kumbaga sa nuclear reaction din, we have types of radiation, but there are also materials here sa Earth na pwedeng i-counteract yun. Okay? Kumbaga, insulators din sa heat and electricity. Okay? Alright, so that's it for the introduction under nuclear chemistry and energy lecture series. So please stay tuned for part 2 of this lecture series. Thank you for listening.